Good morning everyone. Today I will explain you density of substance in its different states. In a previous chapter you have studied about the arrangement of particles in three different states of matter. In solid particles are closely packed, in liquid particles are loosely packed, and in gases particles are very loosely packed, or in simple words they are far away placed. Due to this, interparticle forces among solids become more stronger as comparison to liquid and gases. Therefore, a solid part have more density as compared to liquid and gases. In simple words, we can say that a substance is dense in solid state, less dense in liquid state, and rarer dense in the gaseous state. But there is an exceptional case. Density of ice is less than water. Why? Density of ice is 0.917 gram per centimeter cube, whereas water density 0.998 gram per centimeter cube. Answer for this: because of more stable hydrogen bonds and orientation of hydrogen bond in such a way that causes molecule to push farther apart and lowers the density of ice. Due to this reason, ice floats on water also. Let us take another concept that makes you more understanding about why ice floats on water. That is the principle of floating and sinking. A body floats on liquid if its density is less than the density of liquid, and it sinks in liquid if its density is more than the density of liquid. For example, small piece of wood will float on water. Why? Because density of wood is less than the density of water. Similar with the iron nail. Iron nail will sink in the water. Why? Because density of iron nail is more than the density of water. Principle of floating. When a body dipped in liquid, there are two forces that act on it. Very first, weight of its own body that act vertically downward towards center of gravity, and upthrust that is a upward force also known as buoyant force act upward vertically upon the body by the liquid. Now study about the three cases. Case first: if weight is equal to the force, weight of body is equal to the upthrust force. In this case, net force on the body is zero. Both forces are counterbalance. The body will just float under the surface of liquid. Why? It happens when the density of solid is equal or nearly equal to the density of liquid. In case second, weight is less than force. Weight of the body is less than the upthrust. In such a case, net force on the body acts upward. Some part of body will float above the surface of liquid. It happens. Why? Because the density of solid is less than the density of liquid. In a third case, weight is greater than force. The weight of body is greater than the upthrust force. In such case, net force on body act downwards, and body will sink to the bottom under the surface of liquid. It happens when the density of body is more than density of liquid. You can see that when density of solid nearly equal to the density of liquid, then body just float on the surface of liquid in first case. And in second case, when density of substance is less than the density of liquid, then some part of object remain under the surface of liquid. And when density of substance exceeds to the density of liquid, then body sink at the bottom under the surface of water. So principle of floating states that if the weight of body is equal to the weight of the liquid displaced by, then body floats in the liquid. By an activity, we can prove that body floats with its more portion outside the surface of liquid of more density. For this, our material requirement are two identical small blocks of wood, water, glycerine, two similar beakers. For this, we have to mark 1 and 2nd on the wooden blocks and take water in beaker A and take glycerine in beaker B. Place the block first on the surface of water in a beaker A and second block on the surface of glycerine in beaker B. Block first floats in water with its portion outside the surface lesser than the block second. Result: density of glycerine is more than the density of water. Because of this, block 1 floats in water with its portion outside the surface is lesser as comparison to the block 2nd, because density of glycerine is more than the density of water, and density of wood is less than the density of water as well as density of glycerine. So in both cases, block floats on the surface, but in glycerine, outer portion of block remains outside the surface of glycerine, but in first case, less part remains outside the surface of water. You can see clearly in this diagram also. That makes more clear to you, and you just do comparison. First block and second block, which block portion is remain more outside the surface of two specific liquids, water or glycerine. Now some of the applications of flotation. Application of flotation means uses of flotation in our daily life. The very first, ice floats in water. It is just because of the weight of water displaced by 90% of part of ice dipped inside the water equals to the total weight of the piece of the ice. Means the arrangement of hydrogen bonding in such a way that lowers the density of ice. Therefore, ice floats in water. Swimming in seawater. As sea contains salt, so density becomes more than the density of river water. And seawater gives more upthrust to the swimmer and makes easier to swim in seawater as comparison to river water. Sailing of ship. Ship, you know that it is made up of iron, but it does not sink as comparison to nail. The density of nail is greater than the water and the weight of nail is more than the upthrust of water. The nail sink in the water, but the hollow space of the ship contains air. The average density of ship is less than of water, so ship floats on water. Floating of submarine. Submarine is a special boat which can travel under the water. It has water tanks filled and density of submarine becomes more than the density of sea water, so it sinks. But when these tanks are emptied that are filled with water, density of submarine becomes less than the density of sea water. Then submarine rises up to the surface of water. Icebergs. Huge pieces of ice floating on seawater called icebergs, and density of ice is 0.9 gram per centimeter cube, whereas density of seawater is 1.02 gram per centimeter cube. So density of ice is less than the density of seawater. Then iceberg floats in seawater, but with its major portion under the surface of water. Rising over whales. Whales have air bladder. They fill with the bladder with air to come to the surface of water, and when they empty the air bladder, their average density increases so they can sink inside the water. Gas filled balloon. Density of hydrogen is less than the density of air, so hydrogen filled balloon rises in the air. Upthrust experienced by the hydrogen filled balloon due to the air is more than the weight of the balloon. So it rises up due to the resultant upward force. And the last one is hydrometer. It is a device used to find the relative density of the liquid. Here hydro stands words for moisture, liquid. It is based on the principle of flotation. Similarly, lactometer used to find the purity of the milk, also based on the principle of flotation.